In this video, we're going to go over the KutaSoftware Infinite Calculus free worksheet, differentiation, the product rule. I'll leave a link in the description below so you know how to access this free worksheet. Now quickly, the product rule is the derivative with respect to x of one function f of x times another function g of x. Unlike the sum rule, we can't simply take the derivative of each and multiply. We have to take the derivative of the first function, multiply it by the second function, and then we're going to add that to the first function, multiplied by the derivative of the other function. So one derivative gets multiplied with the original of the other, and then the original gets multiplied with the derivative of the other. So let's look at number 1. In number 1, we're finding the derivative of negative x cubed times 3x to the fourth minus 2. One will be f of x and the other g of x. So like in our formula, we're going to take f prime of x, multiply it by g of x, and then add that to f of x multiplied by the derivative of g of x. So the derivative of f of x will be the derivative of negative x cubed, which will be negative 3x squared. N times x to the n minus 1, that'll be negative 3 times x to the 3 minus 1, which is 2. And then I'll multiply that by g of x, which is 3x to the fourth minus 2. Now that will get added to f of x, which is negative x cubed, times the derivative of g of x, which when we subtract 2, that's a constant, so that will go to 0. So we just need to take the derivative of 3x to the fourth, which will be 3 times 4 times x to the 4 minus 1. So now I'm going to distribute negative 3x squared to 3x to the fourth and negative 3x squared to 2. So writing this out, negative 3x squared will get multiplied to 3x to the fourth, and I'll be subtracting negative 3x squared times 2. And that will get added to negative x cubed times 3 times 4 is 12, so that's 12x to the 4 minus 1, which is 12x cubed. Now I'll simplify by multiplying. Negative 3 times 3 is a negative 9, and x squared times x to the fourth, remember we're adding those exponents when we're multiplying with the same base, so that will be x to the 6th, and then we're subtracting. Negative 3 times 2 is a negative 6, but as opposed to subtracting a negative, we'll add a positive 6, x squared, and then we're adding that to negative x cubed times 12x cubed. So instead of adding a negative, we'll just subtract the positive, and that's going to be 12x to the 3 plus 3, which is 6, remembering the law of exponents. So now I'm going to be able to combine two like terms, negative 9x to the 6th minus 12x to the 6th. So dy dx, the derivative of y with respect to x equals negative 9 minus 12, which is negative 21 x to the 6th plus 6x squared. So that's the derivative of negative x cubed times 3x to the fourth minus 2. Let's move on to number 2. We're looking for the derivative of f of x. So remember, we're taking that first function, or the first part of the function, and multiplying it by the second part. We can think of this as f of x and this as g of x from our formula. So the derivative of x squared will get multiplied by negative 3x squared minus 2. And then we'll be adding that to x squared times the derivative of negative 3x squared minus 2. And that is going to be the derivative of f of x. So the derivative of x squared is 2x, and that's multiplied by negative 3x squared minus 2. And then we're adding that to x squared times the derivative of negative 3x minus 2, which this 2 is a constant, so that part of the derivative will be 0, but negative 3x squared, taking the derivative of that, negative 3 times 2 is negative 6, and that will be x to the first because 2 minus 1 is 1. Now we're going to attempt to combine like terms, but first we're going to need to distribute that 2x to see if there are any like terms. So 2x times negative 3x squared is negative 6x cubed, and I'm subtracting 2x times 2, which is 4x. That gets added to x squared times negative 6x, which is negative 6x cubed. So you can see that now we have a like term, negative 6x cubed and negative 6x cubed. So our derivative of f of x is going to equal negative 6x cubed plus negative 6x cubed, which is a negative 12x cubed, and that's going to be subtracted by 4x. So negative 12x cubed minus 4x is our solution in number 2. In number 3, we have a binomial times a binomial, so it's going to be a little bit more work. So the derivative of our first binomial, negative 2x to the fourth minus 3, will get multiplied by our second binomial, negative 2x squared plus 1, and then that will get added to our first binomial, negative 2x to the fourth minus 3, times the derivative of our second binomial, negative 2x squared plus 1. So the derivative of negative 2x to the fourth minus 3, this 3 is a constant, so that will go to 0, so we'll just find the derivative of negative 2x to the fourth, which 4 times negative 2 is a negative 8, so we'll have negative 8 times x to the 4 minus 1, which is x to the 3, or x to the third. And that will get multiplied by negative 2x squared plus 1. And we'll add that to negative 2x to the fourth minus 3 times the derivative of negative 2x squared plus 1, which that 1 is constant, so that will go to 0, so we'll be taking the 2, multiplying it by 2 to get negative 4, and then x to the 2 minus 1 will be x to the 1, or simply x. So negative 4x is the derivative of negative 2x squared plus 1. Now I'm going to distribute in both of my terms. So negative 8x cubed times negative 2x squared. Negative 8 times negative 2 is a positive 16, and x cubed times x squared will be x to the 3 plus 2, which is x to the 5th. And that will get added to negative 8x cubed times 1. And then we're adding that all to negative 2x to the fourth times negative 4x, which is a positive 8x to the 4 plus 1, because this has an exponent of 1, and x to the 4 plus 1 is 5, and then we're subtracting a negative, so adding a positive 3 times 4x to the first, which will be 12x. So now combining my like terms, I'm combining my terms of x to the 5th. 16 plus 8 is a positive 24. So my derivative of y with respect to x equals 16 plus 8, 24, x to the 5th, minus 8x cubed plus 12x. And that's my solution in number 3. 24x to the 5th minus 8x cubed plus 12x. Let's move on to number 4. So the derivative of f of x is going to equal the derivative of that first binomial, 2x to the 4th minus 3, times my second binomial, x squared plus 1, plus my first binomial, 2x to the 4th minus 3, times the derivative of my second binomial, x squared plus 1. So the derivative of 2x to the 4th minus 3, the 3 will go to 0, so I'm just evaluating the derivative of 2x to the 4th, which, bringing down the 4 to 2, that's going to be 8, and x to the 4 minus 1 is 3. So 8x cubed and that's multiplied by x squared plus 1. And then I'm adding that to 2x to the fourth minus 3 times the derivative of x squared plus 1, which that 1, when taking the derivative, is a constant, so that's going to be 0. So the derivative of x squared is what I'm looking at, and that's 2x. So now I'll distribute my 8x cubed, and I'll distribute my 2x. 8x cubed times x squared is 8x to the fifth, plus 8x cubed times 1 is 8x cubed, plus 2x to the fourth times 2x is 4x to the fifth, because 2 times 2 is 4, and x to the fourth times x is x to the 4 plus 1. And then I'll be subtracting 3 times 2x, which is 6x. Simplifying, I can combine 8x to the fifth and 4x to the fifth. So the derivative of my function f of x is equal to 8 plus 4, which is 12, and that's multiplied by x to the fifth, plus 8x cubed minus 6x. On to number 5. The derivative of f of x is going to equal the derivative of my first binomial, 5x to the fifth plus 5, times my second binomial, negative 2x to the fifth minus 3, plus my first binomial, 5x to the fifth plus 5, times the derivative of that second part, the second binomial, negative 2x to the fifth minus 3. Now 5 is a constant, so that's going to go to 0. So I'm looking at the derivative of 5x to the fifth, which is 5 times 5, which is 25, x to the 5 minus 1, which is x to the 4. And that gets multiplied by negative 2x to the fifth minus 3. Then I'm adding that to 5x to the fifth plus 5, and that gets multiplied by the derivative of negative 2x to the fifth minus 3, but this 3 is a constant, so that derivative will go to 0. So I'm just looking at the derivative of negative 2x to the fifth, which negative 2 times 5 is a negative 10, and x to the 5 minus 1 is x to the fourth. Now I can distribute 25x to the fourth and negative 10x to the fourth. 25x to the fourth times negative 2x to the fifth, well, 25 times negative 2 is a negative 50, and x to the fourth times x to the fifth is x to the ninth, because 4 plus 5 is 9. And then I'm subtracting 25x to the fourth times 3, which is 75 times x to the fourth. And that's added to negative 10x to the fourth times 5x to the fifth, so negative 10 times 5 is negative 50, and x to the fourth times x to the fifth is x to the 4 plus 5, which is 9. And then finally, I'm adding 5 times negative 10x to the fourth, which is negative 50x to the fourth. Now on this one, I have two like terms I can combine. Negative 50x to the ninth and negative 50x to the ninth, as well as negative 75x to the fourth and negative 50x to the fourth. So the derivative of f of x equals negative 100x to the ninth, because negative 50 plus negative 50 is negative 100, and that's multiplied by x to the ninth. And then I'll be adding negative 75 plus negative 50, which is a negative 125. So subtracting a positive 125 times x to the fourth. And that's my solution in number 5. For number 6, I'll find the derivative of negative 3 plus x to the negative third, and I'll multiply that by negative 4x cubed plus 3. And then I'll add that to negative 3 plus x to the negative third times the derivative of negative 4x cubed plus 3. The derivative of f of x times g of x plus f of x times the derivative of g of x, where f of x and g of x are separate functions within our function. So when taking the derivative, the constants will go to 0, So the derivative of x to the negative 3 is negative 3 times x to the negative 3 minus 1, which is negative 4. And that gets multiplied by negative 4x cubed plus 3. And then I'm adding that to negative 3 plus x to the negative third times the derivative of negative 4x cubed, which negative 4 times 3 is negative 12, and x to the 3 minus 1 is x squared. Now on to the distribution. Distribute negative 3x to the negative fourth to two terms, and then negative 12x squared to two separate values. Negative 3x to the negative 4 times negative 4x to the third. Negative 3 times negative 4 is a positive 12, and then I'll have x to the negative 4 times x to the third, which is x to the negative 4, plus 3, which results in a negative 1. And that will get added to negative 3x to the negative fourth times 3, which is negative 9x to the negative fourth. And then we'll be adding negative 3 times negative 12x squared, which is a positive 36x squared, plus x to the negative 3 times negative 12x squared, which is negative 12 times x to the negative 1, because negative 3 plus 2 is a negative 1. Now I'll have two terms that I combined. And notice that 12x to the negative 1 plus negative 12x to the negative 1 equals 0. So I have negative 9x to the negative fourth plus 36x squared, which in function notation, I'll have negative 9 over x to the positive 4, because remember, when we have any variable to a negative exponent, we can write that in the denominator as that variable to the positive value of the exponent. So negative 9 over x to the fourth is equivalent to negative 9x to the negative fourth plus 36x squared. We could also write this as 36x squared minus 9 over x to the fourth, if you wanted our degree of 2 in front of our degree of negative 4. So 36x squared minus 9 over x to the fourth. In number 7, I have a polynomial times a binomial. So my derivative of y with respect to x equals the derivative of my polynomial, negative 2x to the fourth plus 5x squared plus 4, times my second function, negative 3x squared plus 2, and then I'm adding that to my first function, negative 2x to the fourth plus 5x squared plus 4, times the derivative of my second function, negative 3x squared plus 2. Finding the derivative of that first function, we know that the constant will become 0. So the derivative equals negative 2 times 4, which is negative 8 times x to the 4 minus 1, which is 3. Because of the power rule, negative 2x to the fourth will become negative 8x cubed. And I'll be adding that to 2 times 5, and then that degree will get subtracted by 1. So 2 times 5 is 10, and x to the 2 minus 1 is x to the first, which is x. So that binomial will get multiplied to negative 3x squared plus 2, and then it will be added to the product of negative 2x to the fourth plus 5x squared plus 4 times the derivative of negative 3x squared plus 2. However, this 2 is a constant, so the derivative of a constant will be 0, and negative 3x squared, taking the derivative of that, will get negative 6x to the first, because negative 3 times 2 is negative 6, and x to the 2 minus 1 is x to the 1, or simply x. So now I'm going to have to FOIL my first two binomials. First, outside, inside, last, and then distribute this negative 6x to each of my terms for the second half. So starting with our first terms, negative 8x cubed times negative 3x squared, that's going to be negative 8 times negative 3, which is a positive 24, and then x cubed times x squared, is x to the 3 plus 2, which is x to the 5th. So that's my first terms. Now my outside terms, negative 8x cubed times 2, that's going to be a negative 16x cubed. Now my inside terms, 10x times negative 3x squared. 10 times negative 3 is negative 30, and x times x squared will be x cubed. So that'll be negative 30x cubed. So first, outside, inside, and now my last terms, 10x times 2 is 20x. And this will all get added to negative 6x times negative 2x to the 4th. Negative 2 times negative 6 is a positive 12, and x to the 4 plus 1 is x to the 5th, because x to the 4th times x is x to the 5th. And that's going to be added to negative 6x times 5x squared, which 5 times negative 6 is negative 30, and x squared times x is x cubed, plus 4 times negative 6x is a negative 24x. So it seems like a lot, but we're going to be able to simplify. 24x to the 5th can be combined with 12x to the 5th, and that's going to give me a positive 36x to the 5th. Now I'll be able to combine negative 16x cubed, negative 30x cubed, and negative 30x cubed. Well, negative 30 plus negative 30 is negative 60, and when I subtract 16, or add a negative 16 to that, that's going to be negative 76x cubed. So subtracting 76x cubed, and then lastly, I have 20x and negative 24x. 20x minus 24x is going to be a negative 4x. So subtracting 4x. And that is my derivative. 36x to the 5th minus 76x cubed minus 4x. Now on to number 8. For number 8, the derivative of y with respect to x is going to be the derivative of my first function, x to the 4th plus 3 times the second function, negative 4x to the 5th plus 5x to the 4th plus 5, and that will get added to x to the 4th plus 3 times that derivative of that second function, negative 4x to the 5th plus 5x to the 4th plus 5. So starting towards the left, we have x to the 4th plus 3, and we're taking the derivative. The derivative of a constant is 0, so we're taking the derivative of x to the 4th, which is 4x cubed. And that gets multiplied to negative 4x to the 5th plus 5x to the 4th plus 5. And then we're adding that to x to the 4th plus 3 times the derivative of negative 4x to the 5th plus 5x to the 4th plus 5. However, that 5 is a constant, so the derivative is going to be 0. So the derivative of negative 4x to the 5th is going to be negative 4 times 5 times x to the 5 minus 1, which is negative 20 times x to the 5 minus 1, which is negative 20 times x to the 4th. And that's going to be added to the derivative of 5x to the 4th. 4 times 5 is 20. And then I'll have x to the 4 minus 1, which is x to the 3rd. So now I'm distributing 4x to the 3rd to each of my terms in my trinomial, and then x to the 4th will get multiplied to each terms in my binomial, and so will 3. Remember, first, outside, inside, last. So let's solve by multiplying out. 4x cubed times negative 4x to the 5th. 4 times negative 4 is negative 16. And x cubed times x to the 5th is x to the 8th. And that's going to be added to 4 times 5, which is 20. And then x to the 3rd times x to the 4th is x to the 3 plus 4, which is x to the 7. And we're adding that to 4x cubed times 5, which is 20x cubed. Then we'll add, multiplying our first terms, x to the 4th times negative 20x to the 4th is negative 20x to the 8th, because 4 plus 4 is 8. Then we're adding our outside terms, x to the 4th times 20x cubed, which is 20x to the 7th. And then our inside terms, 3 times negative 20x to the fourth, I'll be adding a negative 60x to the fourth, and then 3 times 20x cubed, that's going to be 60 times x cubed. Now I'll be able to combine all my like terms to simplify. Negative 16x to the eighth and negative 20x to the eighth can be combined together to get negative 36x to the eighth. And this is for the derivative of y with respect to x. So combining those, we'll get negative 36x to the eighth, and then we can combine 20x to the seventh with 20x to the seventh to get a positive 40x to the seventh. So plus 40x to the seventh. My next highest degree is x to the fourth, but there's no other terms with x to the fourth, so I'll just write negative 60x to the fourth by subtracting that 60x to the fourth. And then finally I can combine my last two terms, 20x cubed and 60x cubed. 20 plus 60 is 80, so that'll be plus 80x cubed. So my derivative of y with respect to x in number 8 is negative 36x to the 8th plus 40x to the 7th minus 60x to the 4th plus 80x cubed. Let's continue on to the second page. So in number 9, I'm taking the derivative of 5x to the 4th minus 3x squared minus 1, and I'll multiply that by negative 5x squared plus 3. Then I'm adding all of that to 5x to the 4th minus 3x squared minus 1 times the derivative of negative 5x squared plus 3. So the derivative of 5x to the 4th minus 3x squared minus 1, well, the derivative of a constant is 0, so we're just looking at 5x to the 4th minus 3x squared. So the derivative of that, 4 times 5 is 20 times x to the 4 minus 1 is x to the third, and then we're subtracting 2 times 3, which is 6, times x to the 2 minus 1, which is x to the first, or simply x. And that gets multiplied by negative 5x squared plus 3. Then we're adding that to 5x to the 4th minus 3x squared minus 1 times the derivative of negative 5x squared plus 3. This 3 is a constant, so that derivative is 0. So we're looking at negative 5x squared, which that derivative is negative 10x. So foiling and distributing, I'll go ahead and expand this out and then simplify. 20x cubed times negative 5x squared is negative 100x to the 3 plus 2, or x to the fifth. And then I'll add that to 20x cubed times 3, which is 60x cubed. And that will get added to negative 6x times 3, which is negative 18x, and then add it to negative 6x times negative 5x squared, which is a positive 30x to the 1 plus 2, or 30x to the third. Then we'll add that to 5x to the 4th times negative 10x, which is negative 50x to the 4 plus 1, so negative 50x to the fifth. And then we'll add that to negative 3x squared times negative 10x, which is a positive 30x to the 2 plus 1, or x cubed. And then we'll add that to negative 1 times negative 10x, which is a positive 10x. Now combining all my like terms, I'll start by combining my highest degree of x to the fifth. So negative 100x to the fifth minus 50x to the fifth equals negative 150x to the fifth. And then I have 60x cubed, 30x cubed, and 30x cubed to give me a positive 120x cubed. And then lastly, I'll combine negative 18x with a positive 10x to get negative 8x, so I'll subtract 8x. Therefore, the solution dy dx at number 9 is negative 150x to the fifth plus 120x to the third minus 8x. Now let's move on to number 10. So I'm going to take the derivative of that first part, negative 10x squared minus 7 times x to the 2/5, because the 5th root of x squared is the same as writing x to the 2/5, plus 9. That will get multiplied by 2x cubed plus 4. Then I'll be adding that to the first polynomial, negative 10x squared minus 7x to the 2/5 plus 9 times the derivative of my second polynomial, 2x cubed plus 4. Now, taking the derivative of my first polynomial, 2 times negative 10 is negative 20. So I'll have negative 20 times x to the 2 minus 1, which is x to the 1, so negative 20x. And then I'll be subtracting 7 times 2/5, which is 14/5, times x to the 2/5 minus 1. But 2/5 minus 1 is 2/5 minus 5/5, which is a negative 3/5. And I'm adding that to the derivative of our constant 9, which is 0. So that gets multiplied to 2x cubed plus 4, and then added to the quantity negative 10x squared minus 7x to the 2/5 plus 9 times the derivative of 2x cubed plus 4, which this 4 is a constant, so that derivative is 0. So 2x cubed, that derivative is 2 times 3, which is 6, times x to the 3 minus 1, which is x squared. Now I'll be foiling my first two binomials, and then I'll be distributing 6x squared to my polynomial. So negative 20x times 2x cubed is negative 40x to the 1 plus 3, or x to the 4th. Negative 20x times 4 is going to be a negative 80x, so minus 80x. And then I'll be subtracting 14/5 x to the negative 3/5 times 2x to the 3rd, which will be 28/5 times x to the negative 3/5 plus 3. So we can think of this as negative 3/5 plus 15/5, because 15 divided by 5 is 3. So negative 3 plus 15 is a positive 12. The positive 12/5. So again, negative 3/5 plus 3 equals 12/5. And then that's added to negative 14/5 x to the negative 3/5 times 4, which is negative 56/5 times x to the negative 3/5. So then I'll add that to negative 10x squared times 6x squared, which is negative 60x to the 2 plus 2, or x to the 4. And then I'll add that to negative 7 times 6, which is negative 42x to the 2/5 plus 2, which is plus 10/5, and 2 plus 10 is 12. So that's negative 42x to the 12/5. And then I'll add that to 9 times 6x squared, which is 54x squared. So now, combining my like terms, negative 40x to the 4th and negative 60x to the 4th, the derivative of my function is going to equal negative 100 x to the 4th, and then combining my next degrees, that'll be negative 28/5 x to the 12/5 and negative 42x to the 12/5, which I'll be subtracting, writing 42 in terms of fifths. 42 can be written as 210 over 5. So negative 28 minus 210 is going to be a negative. So we're subtracting 238 times x to the 12/5, and that's all over 5. And all my other terms cannot be combined. So then I'll add 54x squared, and then I'll subtract 80x, and then finally I'll subtract 56 over 5 times x to the negative 3/5. So again, now I'll add 54x squared, then I'll subtract 80x, and then I'll subtract, because this negative was added originally, so now I'll subtract the positive 56 all over 5 times x to the positive 3/5, because I'll rewrite x to the negative 3/5 as 1 over x to the positive 3/5. So my solution in number 10 is negative 100x to the 4th minus 238x to the 12/5 over 5 plus 54x squared minus 80x minus 56 over 5x to the 3/5. Now let's move on to number 11. So the derivative of f of x times g of x, that's going to be, well, the derivative of 5 is 0, so looking at the derivative of 3x to the negative 2, that's going to be negative 6x to the negative third, because negative 2 times 3 is negative 6, and negative 2 minus 1 is negative 3. And that'll be multiplied by our g of x, so to say, so 4x to the 5th plus 6x cubed plus 10. And then we're adding that to f of x, not the derivative, but f of x itself, which is 5 plus 3x to the negative 2, times the derivative of g of x, which 4x to the 5th would become 20x to the 4th, 6x to the 3rd, using the power rule, 3 times 6 will be 18, x to the 3 minus 1, which is 2, so 18x squared is the derivative of 6x cubed, and then we're adding 0 because the derivative of a constant is 0, but we don't need to write that in. So now I'm going to expand this out, multiplying my negative 6x to the negative 3 to each of my terms in the polynomial, and then foiling the next two binomials. Negative 6x to the negative 3 times a positive 4x to the 5th, that's going to be negative 24, and I'll have x to the negative 3 plus 5, which is x squared. And that will get added to negative 6x to the negative 3 times 6x to the 3, which negative 6 times 6 is negative 36, and x to the negative 3 plus 3 is x to the 0. But we know that x to the 0 is 1. So this will be 36 times 1, or simply 36. And then we'll be adding that to negative 6x to the negative 3 times 10, which is negative 60x to the negative 3. So now, my first terms, 5 times 20x to the 4th is 100x to the 4th, plus 5 times 18x squared is 90x squared, plus 3x to the negative 2 times 20x to the 4th is 60x to the negative 2 plus 4, which is x squared. And then my last terms, so first, outside, inside, and now last, 3x to the negative 2 times 18x squared will be 54 times x to the negative 2 plus 2, which is x to the 0, which x to the 0 we know is multiplying by 1. Now I'll combine my like terms. My x squared terms will be combined, and my constants will be combined. So writing this in order of degree, we'll have the derivative of y with respect to x equal to 100x to the 4th plus, now time for my x squared terms, negative 24 plus 90 plus 60 is 126, so that's a positive 126x squared. Now time for my constant, negative 36 plus 54 is a positive 18. And then lastly, negative 60x to the negative 3, that's subtracting 60 all over x to the positive 3. So my derivative at number 11 is 100x to the 4th plus 126x squared plus 18 minus 60 over x cubed. And again, I simplified, combining my like terms. However, there were two terms that could not be combined with anything else, and that was negative 60x to the negative 3 and 100x to the 4th. So those were just rewritten. Now on to number 12. So in number 12, the derivative of the polynomial times the binomial plus the polynomial times the derivative of the binomial. So this is going to be negative 6x to the 4th. I'm going to take the derivative of that to get negative 24x to the 4 minus 1, which is x cubed. the derivative of 2 is 0, and the derivative of 6x to the negative fourth is negative 24x to the negative fifth, because negative 4 minus 1 is negative 5, and negative 4 times 6 is negative 24. So that's the derivative, and then that will be multiplied to 6x to the fourth plus 7. So then I'll add that to that polynomial, negative 6x to the fourth plus 2 plus 6x to the negative fourth times the derivative of my binomial, 6x to the fourth is 24x to the third, because 4 times 6 is 24, and x to the 4 minus 1 is x cubed, and then the derivative of 7 is 0, which I do not need to put in. Now I'm going to distribute, foiling, and then distributing 24x cubed. So expanding all of this out, negative 24x cubed times 6x to the fourth is negative 144x to the 3 plus 4, which is x to the seventh. And that's going to get added to negative 24x cubed times 7, which is negative 168x cubed. And then I'm adding negative 24x to the negative fifth times 6x to the fourth, which negative 24 times 6 is negative 144 times x to the negative 5 plus 4, which is x to the negative 1, and that gets added to negative 24x to the negative fifth times 7, which is negative 168x to the negative fifth. Now I'll add that to 24x cubed times negative 6x to the fourth, which is negative 144x to the 4 plus 3, or x to the 7. Then I'm adding that to 24x cubed times 2, which is 48x cubed, and then adding that to 24x cubed times 6x to the negative fourth. 24 times 6 is a positive 144, and x to the negative fourth times x to the third is x to the negative 1. So now I'll be able to simplify by combining like terms. Negative 144x to the seventh plus negative 144x to the seventh gives me negative 288x to the seventh. Then I can combine negative 168x to the third with 48x to the third to get a negative 120x to the third, so subtracting 120x to the third, and then you can see that negative 144x to the negative 1 plus 144x to the negative 1 will be 0, so those will cancel out. So all I'll have left is negative 168x to the negative fifth, which I'll write as subtracting 168 all over x to the positive 5, or x to the fifth. So my derivative in number 12 will be negative 288x to the seventh minus 120x to the third minus 168 over x to the fifth. Let's continue on to number 13. Now in number 13, I'm going to take the derivative of the first function, multiply it by the second, then take the derivative of the second and multiply it by the first. So that first derivative, negative 7x to the fourth, will be negative 7 times 4, so that's negative 28x to the 4 minus 1, which is x to the third. And I'll be adding that to 10x to the 2 fifths, which is going to be 10 times 2 fifths x to the 2 fifths minus 1, which 2 fifths minus 1 is going to be a negative 3 fifths, because we can think of that as 2 minus 5, which is a negative 3, and that's all over 5. And then we're adding that to 0 because the derivative of 8 is 0, but we don't need to write that in. So this, the derivative of the first function, will get multiplied by the second function, x squared plus 10, and that will be added to the first part of our function, or the first polynomial, negative 7x to the fourth plus 10x to the 2 fifths plus 8 times the derivative of x squared plus 10, which the derivative of constant is 0, so we're just looking at the derivative of x squared, which is 2x. So now we're going to need to distribute, but before I do that, I'm going to simplify. So I'll have negative 28x cubed plus 10 times 2/5 is going to be 20 over 5, which equals 4. So that's 4x to the negative 3/5. And that's the part I wanted to simplify. So that gets multiplied by x squared plus 10, and then added to negative 7x to the 4th plus 10x to the 2/5 plus 8 times 2x. So now expanding our first binomials. First, outside, inside, last, foiling them. Negative 28x cubed times x squared is negative 28x to the 5th plus negative 28x cubed times 10 is negative 280x cubed plus 4x to the negative 3/5 times x squared is going to be 4x to the negative 3/5 plus 2, but 2 written in terms of 5 is 10/5, and then that will get added to 4x to the negative 3/5 times 10, which is 40x to the negative 3/5. And that's all added to. Now I'll distribute my 2x. So 2x times negative 7x to the 4th is negative 14x to the 5th plus 2x times 10x to the 5th is going to be 20x to the 2/5 plus 1, which will be 7/5, and then plus 8 times 2x is 16x. Now I'll start combining like terms. Negative 28x to the 5th can be combined with negative 14x to the 5th, and that will give me negative 42x to the 5th. Now, I only have one term with x to the 3rd, and that's negative 280x to the 3rd. So subtract 280x to the 3rd. Then you can see that negative 3/5 plus 10/5 is a positive 7/5. So 4x to the 7/5 can be added to 20x to the 7/5 to give me a positive 24x to the 7/5, or x to a power of 7 over 5. And then I'll add that to 16x, and there's no other term that can be combined with 16x. And then lastly, my 40x to the negative 3/5, and that's going to be added, but because this exponent's negative, I'll write x to the 3/5 in the denominator. So 40 over x to the positive 3/5. So negative 42x to the 5th minus 280x cubed plus 24x to the 7/5 plus 16x plus 40 over x to the 3/5 is my solution in number 13. Continuing on to our critical thinking question, it says, a classmate claims that the derivative of f times g equals the derivative of f times the derivative of g for any functions f and g. Show an example that proves your classmate wrong. And this is quite easy to prove wrong. For example, let's make f equal to 2x, and let's make g equal to 4. So if we calculate f times g, the derivative of that, so we're taking the derivative of f times g, which is 2x times 4, so the derivative of 8x, which equals 8. Now the derivative of f times the derivative of g equals, well, the derivative of f is 2 times the derivative of g. G is a constant, so that derivative is 0. 2 times 0 is 0. And right away, we can see that 8 does not equal 0. So here's one example that proves our classmate is wrong. F equal to 2x, g equals 4, and we can show that 8 does not equal 0. Another example, let's say that f equals x squared and g equals 3. Then f times g, the derivative of that, equals x squared times 3, so the derivative of 3x squared, which equals 6x. And then if we take the derivative of f and multiply that by the derivative of g, well, the derivative of f is 2x and the derivative of g is 0 because the derivative of constant is 0 and 2x times 0 equals 0 and 6x does not equal 0. So feel free to come up with your own example and leave it in the comments below. And if you haven't done so already, don't forget to like, subscribe, and share. Also, if you want to show more support, become a patron. Go to my Patreon link in the video description to find out more.